This video, we're going to review how to complete the square to turn something into vertex form. So remember, if you have a plus b squared, that's not equal to a squared plus b squared. Why? That's because if you expand it out, you're going to get a squared plus ab again plus b squared. So it's actually a squared plus 2ab plus b squared. So, if you want to make something into a perfect square, it needs to look like this. Let's do the first one to make that perfect square. So you have x squared and you have 25, and you have to guess at the middle term. So you'll see that the first term should be a squared, right? That means a should be x. The second term is, sorry, the last term is b squared. So that means b should be 5. Although it could also be negative 5. So what's the middle term? Well, if it's a middle term, this should be 2ab. 2ab is going to be 2 times x times plus or minus 5. So it could be like plus or minus 10x. So to write out both of those possibilities, I didn't leave myself very much space here. If we did x squared plus 10x plus 25, that would be x plus 5 squared. And if we did x squared minus 10x plus 25, that would be x minus 5 squared. Okay, let's do the second one. We're trying to say x squared plus 6x plus some mystery number. What mystery number gives us a perfect square? We're going to say, we know a should be x, right? And this should be 2ab. Okay, we know a is x, so that means 2b is going to be 6. So b should be 3. So finally, this term should be b squared, which is 9. Okay, so it's x squared plus 6x plus 9. That's going to give you x plus 3 squared. Now, if you don't like that method, there's also a visual method that I'm particularly fond of because you're literally completing a square. So you're going to imagine that this is an area, okay? Area, remember, is length times width. So if you were to say, okay, how do I make a rectangle with a length and width, with an area of x squared plus 6 times 6 plus 6x? That's like x by x plus 6. Now we're going to cut this in half. And we're going to take this rectangle and move it over here. So if you think about the areas, this rectangle should be only 3x now, and this should also only be 3x. Hard to see. Let me put in a different color. 3x, 3x. So the dimensions now are x and 3, x and 3. That is almost a square, isn't it? Right? You want to find what this little bit is to fill in the square, to complete the square. And that's a 3 by 3 rectangle, or 3 by 3 square. So that's 9. So therefore, that's a 9. And you're going to say this is x plus 3 squared because it's a square with side length x plus 3. Okay. Next example, x squared minus 5x plus some mystery number. So we could draw the picture again. X squared, negative 5x. Dimensions are x by x plus negative 5. We're going to cut this down the middle and take this and move it over here. And this is going to be negative 5 halves x and negative 5 halves x. So your dimensions are going to be x minus 5 halves and x minus 5 halves. What's left over? That's this square. That's going to be negative 5 halves times negative 5 halves, or negative 5 halves squared, which is 25 over 4. So that's a mystery number, and that makes this x minus 5 halves squared. Now, if you want to do this faster, you can say, in general, if you have x squared plus bx and you want to complete the square, you want to take the middle coefficient b and you want to cut it in two, because that's what we've been doing, and you want to square it for the last term. And then you're going to get x plus b over 2 squared. So if you want to do the last example that way, we're going to take the middle term, which is negative 5, cut in half, negative 5 over 2, square it, and that is actually equal to x minus 5 over 2 squared. Now let's apply this to turn some quadratic functions into vertex form. So for f of x, we have x squared minus 10x. Let's try that new trick. Okay, we're going to notice that make it a perfect square, we're going to take the x coefficient, which is negative 10. We're going to have it, which is negative 5, and we're going to square it. Now we can't just add it. If we add it, we should also subtract it so that we're actually not doing anything to the function. So that's going to look like x squared minus 10x plus 25 minus 25. Now, what was the point of that? Well, this first three terms, the whole point of that is that it's a perfect square. It's x minus 5 squared. So now, it's in vertex form. If we were to quickly graph that, the vertex is 5, negative 25. Let's say that's 5. That's not a scale. A negative 25. Vertex is here. And it should look something like this. It's concave up. Domain, all real numbers. The range, well, it's got to be, y has got to be greater than or equal to negative 25. Let's try the same with g of x. Now you'll notice two complicating factors here. First is a is no longer 1. So we need to factor that out first. The other thing is there's a 14 here. We're going to basically ignore it. Well, we're going to write it down every time. We're going to ignore it until the very end. So let's say step 1 is to factor out a from the x squared and x terms. Okay, we're going to complete the square. We're going to distribute a. You'll see what I mean by that. And you're going to combine the constants to find k. You'll see what I mean by that. So first step, factor out a. Just from the first two terms, we're going to get x squared minus 8x. And you'll notice that inside here is something that we can very easily complete the square for by using that trick. So inside this bracket, we're going to say we're going to add some mystery number to make it a perfect square. What is this mystery number? Well, you're going to take b, which is -8. You're going to divide it by 2, which is -4. You're going to square that. It's going to be 16. But you can't just add 16. You got to also subtract 16 inside the bracket, so you didn't really do anything. Now that we have this beautiful perfect square, we're going to write it as a perfect square. X minus 4 squared. And now that we have a square here, we're not going to touch it. Okay, imagine this as a box. Then we're going to distribute A. Let me label my steps here. This is step 2. Step 3, we're going to distribute A. So 3 times this and 3 times that. So 3 times x minus 4 squared, and then 3 times -16, which is -48. Finally, they're going to combine the constants to find k. So -48 plus 14, that's going to be -34. And there's our vertex form. So to draw a quick sketch, okay, we know our vertex is at 4, -34. Let's say somewhere here. We know that it's A is 3, so it's concave up. Something like this. Domain, all real numbers. The range, y has got to be greater than or equal to -34.